There is one more question that I'd like to answer, and it is, how would you convert an inode table offset to the actual inode number? So the idea behind this is, if we're looking at a specific inode inside the inode table, and we know what is the offset of this inode, how do you compute the index of this inode? So let's first try this directory lost plus found. You can go right here, click on the name of the directory, right click, position, and jump to inode. Just go to inode. So what we get here in WinHex is an absolute byte offset from the beginning of the drive, which points to the location of this inode structure on our drive. So of course this inode is located somewhere inside inode table. It's one of the inodes. So this value 6400 bytes is offset of this inode from the beginning of the drive, right? So there's like a boot sector in front of it, and this is an absolute offset. At the same time, earlier we also remembered the byte offset of the inode table itself, and it was 5120. So we also know absolute offset of this location, the beginning of the inode table. And therefore, knowing these two positions, the beginning of the inode table and the beginning of our inode that we just located, allows us to basically compute the difference, 6400 minus 5120, so the result is 1280, divided by 128, because that's the size of every inode. Basically, we're trying to figure out how far away, how many inodes are preceding this inode, and the result is 10. And 10 would be a correct number if the first inode number was 0. But because the first inode number is 1, so this first inode that we get here is 1, we actually have to add plus 1. So of course this brings us, this type of computation brings us to inode 11, and we already know that the inode of this lost plus found is inode 11. Let's try another example, for instance, system file journal. So we can click this file in the directory browser, and we can just simply go to position and jump to inode. So we jump to this inode, and we recognize the absolute offset of this inode in the inode table is 6016, right? So this value 6016. So this is the offset of this inode in inode table. So somewhere here we have this inode which describes the metadata of journal. And then we do the same thing. We take 6016 minus 5120. So this, of course, 5120 is the beginning of the inode table. So we take this difference, right? So we compute this difference. It equals 896. And we divide it by 128, so that results in 7, but we have to make an adjustment. 7 plus 1 is inode 8. So a journal has inode number assignment 8. And I'm trying to show you this computation, because when you go to inode for any file or directory, and you end up looking at the beginning of this inode, inside the block, what's shown here in the details panel, it tells us that we're actually looking at block number 5, and it just shows the range of inodes 1 through 8. So basically in this 1 kilobyte block we have as many as 8 inodes that fit in there. So you just don't know which one this is, but there is a way to compute that this is actually inode 8 the last inode in this block or describes the metadata of system journal file.